Good morning, good afternoon, and good evening, everyone, wherever in the world you may be joining us from today. My name is Francesco Del Carpio, and I am the CFL York Operations Coordinator. I would like to officially open the sixth session of the Drones for Public Health, Safety, Risk, Humanitarian, and Emergency Management Speaker Series, presented in partnership with York University's Advanced Disaster and Emergency Rapid Response Lab, or ADDERSON, and the Southern Alberta Institute of Technology's Center for Innovation and Research in Unmanned Systems, or SAIT series. I would like to begin today's session with a land acknowledgement. We acknowledge and recognize that many Indigenous nations have long-standing relationships with the territory upon which our campuses are located that precede the establishment of York University. The area is known as Tkaronto and has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit, and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation, and that the territory is subject to the Dish with One Spoon Wampum Belt Covenant, an agreement to peaceably share and care for the Great Lakes region. As this is an online event, our participants may be joining from various locations, so I strongly encourage you to learn about the traditional land upon which you are located. With this, I welcome our moderator, our speaker, and our participants from around the world. Welcome to our webinar. I would now like to introduce our moderator today, Michelle Arif. Michelle is a research staff and geospatial analyst at the Center of Innovation and Research in Unmanned Systems at the Southern Alberta Institute of Technology. She holds a master's degree in disaster and emergency management from Royal Roads University, as well as an applied bachelor's in geographic information systems from SAIT and an undergraduate degree from the University of Toronto. Her research interests focus on how climate change influences disaster patterns and how emerging technologies, such as drones, can aid in disaster mitigation efforts. Additionally, Michelle actively volunteers with the Canadian Red Cross, contributing to the emergency response team and personal disaster assistance programs. Michelle, thank you very much for moderating today's session and your ongoing support throughout the series. The floor is yours.
Thank you, Francesco. Good morning and good afternoon to everyone that's joining us here today, and thank you all for taking the time to learn with us. We have a fantastic speaker lined up for today, which I'm very excited to introduce. But before I do, I'd like to go over a few housekeeping rules. As Francesco mentioned, I'll be the moderator for today, which includes moderating the chat box and the Q&A box. The chat box is now open. Feel free to pop in where you're joining us from. It's great to see some repeat attendees, but lots of new faces and names in there. So feel free to share where you're joining us from. The Q&A box is also open. That is for those burning questions you have for a speaker. I'll be monitoring that through our session and address the questions in there at the end of our talk. So with that said, our speaker today is Vaidehi Jadeja. Vaidehi is a graduate from the University of Waterloo, a licensed environmental engineer, and a true certified advisor with nearly a decade of consulting experience. In her role at RPASOTC, she combines technical expertise and innovation to continuously explore aerial solutions for both operational efficiency and environmental progress. She has worked with a diverse group of clients across Canada and internationally, providing tailored, data-driven drone solutions to optimize operations and implement sustainable practices that reduce environmental impact. As both an engineer and a Transport Canada certified advanced operations drone pilot, Vaidehi is committed to harnessing drone technology to drive smarter and more efficient workflows. Outside of her professional pursuits, she enjoys playing the violin, reading, and exploring new creative outlets. Today, Vaidehi will be focusing on drones in the environmental science space and speaking about innovations in bathymetric mapping, mineral exploration, contaminant tracking, and vegetation health monitoring. With that said, I'm delighted to introduce our speaker, Vaidehi. The floor is yours.
Great. Thank you so much, Michelle, for that introduction. Hello, everyone. Welcome to the session. I'm really excited to be here today. So as Michelle mentioned, I am an environmental engineer. I will just share my screen here so you can see the presentation. Just a sec. Okay. Yeah, so I'm an environmental engineer. I've been working in the consulting industry for about 10 years now, and I've made the switch to specifically working with drones in the last 4 to 5 years. I work with a company called RPASOTC, which is RPAS is Remotely Piloted Aircraft Systems, and OTC stands for Operations and Training Corporation. So we specifically work with people to either get their drone licenses if anybody is interested in becoming a drone pilot themselves. And we also conduct a lot of commercial operations across Canada and internationally to help clients obtain aerial data for their requirements. So today, as Michelle mentioned, I'm specifically focusing on some projects that RPASOTC has conducted over the years for various clients, which are focused specifically in the environmental field. Let's get started. So first of all, I know that a lot of you may already be aware of drones and what drones are used for in various industries and how they have obviously changed, dramatically changed the whole landscape for a lot of industries. But I just thought I'll just give some background information in case anybody's not familiar with how drones have been helping with various industries. So obviously the importance of drones nowadays has increased a lot. They are helping industries become very much more efficient and working a lot faster nowadays, with a lot of focus on obtaining data-driven quality information, as opposed to having a lot of people out there in the field working multiple hours and reducing that significantly. So as I said, data collection efficiency, disaster response, emergency management services use drones a lot like this. Drones have effectively known to reduce labor and reduce safety concerns significantly in the industry, right? So environmental monitoring has also found, based on certain surveys that have been done and certain reports that have been published, that it can increase surveys, the time taken to conduct surveys, by about 400%. Infrastructure inspections, companies that use drones for power lines, or even something like wind turbine inspections, which we have conducted in the past, they can be increased by about 30 to the cost can be reduced by about 30 to 50% when you are using drones, as opposed to manual labor of having people up there and out in the fields doing these inspections. So just speed and efficiency can be increased significantly. Data collection, we're getting real-time, high-resolution imagery from drone mapping. Thermal scans can be done. It can really help make decisions a lot quicker in the field and during project management, and because you're getting real-time data right at your fingertips, and it's generally, the turnaround time is generally pretty quick as well. Obviously, there's a lot of cost savings that have been achieved due to using drones out there rather than sending people out there, and the main human factor is that you are reducing risk significantly as well. For example, for wind turbine inspections, having someone out there up 400 feet hanging from harnesses and conducting inspections, but you can just quickly send out a drone remotely and have the inspection done within a fraction of the time and the cost that it would take to do the same. So overall, of course, as we know, that drones can significantly improve operations out in the field and can provide a lot of information in a fraction of the time and cost required from traditional methods of doing the same kind of work. So just to give you a quick overview of certain types of drones out there and some payloads that we at RPASOTC use as well, and of course others use out there. So we have various types of drones that are used: fixed wing drones, multi-rotor drones, hybrid, VTOL drones. VTOL basically stands for vertical takeoff and landing. So there's various kinds of drones which are used for different types of applications. So the fixed wing drones and the VTOL drones are usually for long distance endurance They're very efficient. They can cover large areas in a very short amount of time. When you have acres and acres of fields or vegetation or farmland that you're looking at, Wingtra, for example, this drone right here can do it in a fraction of the time that it would take somebody to be out there on foot with heavy equipment, and which is a laborious task. And certain payloads is just another term for all the attachments that we use in the drones. Certain drones come with inbuilt cameras, whereas certain drones we can add and change attachments depending on what the requirement is. So we have thermal cameras, we have LiDAR, which is LiDAR cameras, multispectral imaging, which is various different types of cameras, which emits infrared light, which is not visible to the light that is not visible to the human eye. We have gas and chemical sensors and detectors. We have medical supply payloads for vaccines or any kind of emergency kits that need to be delivered. So there's a lot of various different types of drones that are used in the industry these days. And the projects that I'll be discussing will go through some of these drones that RPASOTC has used in the field, and some of the payloads as well that we use to conduct certain certain operations. This is just a picture of some of the drones that we have at RPASOTC. This is an M300. A lot of the drones that we own, a fleet of our drones, is DJI. The Wingtra is different. We have a lot of different payloads, as I mentioned earlier, echo sounders, for bathymetric surveys. We have LiDAR cameras, we have thermal cameras, infrared cameras, multispectral cameras. This is M600, which is a 6-prop drone. These are considered multi-rotor drones, whereas this is something which is in hybrid, which is got a fixed wing and also got props as well. And this the Wingtra takes off vertically and lands vertically as well. So there's different features, there's different drones for different applications. So I just wanted to introduce Simba. He's our brand ambassador at RPASOTC. So I just wanted to go through now some of the projects that we discussed that we have done in the environmental space. So let's start with bathymetric mapping. So bathymetric mapping is basically just a hydrographic survey that is conducted to determine the shape of underwater terrain. So it helps provide a detailed representation of the waterbed, basically, by giving us features, terrain features, or depth information and everything. So this was a project that we conducted in the summertime, in the spring and summer for the Environment Canada group. We were working in a section of Lake Erie, which is known to have a lot of nuisance algae that grows in that area. So they were experiencing a lot of problem with the algae coming onto the shore. There was a lot of issues with odor that the nearby residents were complaining about. And so during the spring and the summertime, the algae growth is so significant that the locals are not really able to use that beach area for weeks on end until pretty much the summer is over and the algae dies. So Environment Canada wanted to conduct, this was meant to be a pilot test. So this was a proof of concept study that we conducted for them using an M300 RTK drone. So RTK is real-time kinematics. So this drone is basically has built-in features where it is a satellite-based navigation technology, which provides the accurate location of the data that is being collected. So every photograph that the drone collects is georeferenced and has location and timestamp data as well. So we used the RTK M300 along with the dual frequency ecologger, which is the payload, which is basically the additional equipment that we attached onto the drone. So the M300 was basically utilized to fly the echologger into the water and collect all of this information. So we were basically mapping this section of Lake Erie where the algae is growing significantly to determine the thickness of the algae, and also to map the bed and to see how much algae, like what stage of growth algae is in, and how, basically help us to determine what can be done about it at a later time. So as I mentioned, this was a pilot project, a proof of concept. So we were just using this technology to determine if the echologger, not only to do the bathymetric survey of the Lake Erie, the section of Lake Erie, but also use that to determine the height and the thickness of the algae as well. So how the payload basically works is it's a dual frequency. So it emits two different frequencies. The 400 kilohertz frequency is more detailed imaging. So it'll give you the shallow aquatic environment. So it'll basically map out any seaweed and things like that, or algae, as I mentioned. Whereas the 200 kilohertz frequency penetrates deeper and basically gives you the bed of the water body. So then when you subtract the differences between the two, you'll basically see the thickness of any kind of vegetation or sediment or anything that's at the bottom of the water body. And then the dual EcoSounder also has temperature sensors in it, and also has tilt correction for tilt and everything. So in case there's any shallow areas where the EcoSounder ends up tilting because it's hitting the bottom or rocks or anything like that, it still accounts for that and corrects for it and everything. So that helps give you more accurate data, and it's pinging every second. So it's collecting. You can change the amount, like how much information you want, how much data you want to collect. So it'll change the pinging and the amount of data that's being collected based on your settings and what you require. So basically, this is what the equipment looks like. So this is the M300 drone, and this is the ecologger that is generally suspended about 3 meters, 1.5 to 3 meters below the drone into the water, and then just a few centimeters into the water. It has to be submerged in the water for it to ping and receive the data that it requires. So sorry, I didn't. I explained just the way the equipment works is that it emits this frequency which bounces back. Basically, it's like sound waves. So it emits the sound wave, and then the amount of time it takes for it to bounce back is what determines the height of the algae or sediment or anything that's in its way. And as I said, the 200 kilohertz frequency will hit the bottom and then basically give you the bottom terrain mapping. So why we used this? I mean, it was a proof of concept to help them understand that there is equipment out there that can help determine or provide them the information that they're looking for. It was non-intrusive. We were not out there in a boat or doing anything to disturb or and disturb the aquatic life. It was non-intrusive. It was just about a few centimeters into the water, so it wasn't disturbing anything. The precision of the dual frequency really helps with the shallow and deep areas as well. The location we were mapping was just about 2 meters deep, so we weren't looking at that deep of an area. However, it is capable of doing a lot deeper if needed. The cladophora, which is the technical term for the algae that we were monitoring, it was able to provide us, it was able to provide information regarding that as to what the quality of it was, what stage of growth it was in, and the thickness of it as well. And the real world applications of this is obviously, the data supports environmental agencies to obtain the significant and relevant data which is required for researchers or for monitoring aquatic ecosystems. It helps in predicting the algal bloom patterns. So the idea was for us to do this twice in the year. Earlier in the algal earlier in the stages where the algal bloom hadn't yet grown or was just in the starting phases, and then towards the end where it was in full growth. So to determine the difference in the growth patterns and to see how quickly the algae is growing as well, and how it can be then addressed later on once they figure out how they want to contain it. And it contributes to better decision making. So of course, the amount of data that you receive and the formats that you receive it in will help the right authorities make the right decisions about how they want to progress further with that project. So the good thing about this was, so the post-processing of this data that we received was done in an app called Hydromagic. This software basically gives you the option of outputting it in various different formats. So you can get a full color depth elevation map of and contours of the body that you're monitoring. You can receive cross-section profiles. So the two lines that you see here are representative of the two frequencies that I discussed. You can get CSV files with coordinates and the depths and everything. So you can have the depths of the bottom, and then you can also have the depths of where it pinged for the algal bloom. So you can then subtract the difference and get the height of the algae, or you can get data in the form of a point cloud. Which is just an extensive amount of data, and it'll create like a 3D image of the actual location that was mapped as well. And this is called an echogram. So this is also one of the outputs. So this is exactly showing you the two different frequencies. The 450 or the 400 kilohertz will show where it hits any of the sediment or any of the algae. So it gives you all the hits that it's getting as it's going across the water body. And the 200 kilohertz will give you basically the baseline, which is the bottom of the water. And it'll then subtracting this difference will give you basically the approximate height of the algal bloom or whatever it is that you're monitoring. So that was bathymetric mapping that we conducted in the summertime. Vegetation health monitoring is another project. So this was actually done in the same location. So this was kind of complementary to the bathymetric survey that we conducted. So while we did one flight with the M300 RTK drone along with the Eagle sounder attached to it, we did another flight with the DJI Mavic 3 Enterprise multispectral drone. So multispectral drones are basically just drones that have all of these different range of cameras that can detect different light spectrums, which are not visible to the naked eye. So the multispectral drones are generally used a lot in the vegetation and agricultural fields to monitor vegetation health and to help farmers determine crop health, and if there's any requirement for pesticides or fertilizer or anything like that. So this drone, as I said, this flight was conducted in conjunction with the other flight at Lake Erie, where we used the multispectral camera to also obtain data related to the algal bloom. So the multispectral camera takes images of all the different vegetation, and based on how the light penetrates through the vegetation, it can determine the health of the vegetation as well. So the idea was to see what stages, again, the algal bloom was in, depending on whether it was healthy or whether it was in the dying stages and how quickly it was growing or decaying. And that would help us determine what needed to be done in the future about it to help reduce or control that growth so that it's not such a nuisance to the locals at the beach. So the multispectral camera, as I mentioned, captured different spectral bands. NDVI is one term, is a vegetation index that is used very frequently along with using a multispectral camera. So it stands for Normalized Difference Vegetation Index, and it basically helps you calculate the plant health. So I'll just show you this slide first. So These are some of the typical bands that are used for analysis. So the blue, green, and the red will be absorbed differently by vegetation, depending on what stage it is at, how healthy or how decaying it is, and that will help determine the plant health. So when you are calculating NDVI, we generally process the post-processing of the data that we receive from multispectral imaging is done in there are various applications that can be used, but we've used Pix4D fields in the past. This is a program that we use to process the data. So this is just an example of a small snippet of the area that we flew with the multispectral in the section of Lake Erie. And so here you can see the normalized difference vegetation index, NDVI, which was calculated by the program itself. So it gives you a value between 0.6 and minus 0.5, and it'll basically determine, what stages the algal bloom is at. So this specific data is from the end of the algal bloom. So this was almost towards fall that we conducted this flight. And so you can see here, based on the index, that this green portion here is basically where all the healthy trees were along the beach. And then all the orange and the yellow is basically where it's detecting dead algal blooms or possibly sediment as well, because it's just so dark now and there's no real green vegetation or any chlorophyll that the light detected. So this is what the output looks like, which will help you determine the health of the crop. So I'll just go back here. So this is the kind of standard range that is utilized to determine the health of the crop. This is the NDVI, which is output. And so anything close to the -1 mark is either just dead plants or generally sometimes even sediment. And as you get closer to the +1 range, then that determines healthy plant. So again, key applications of this, early detection of disease and stress to the plant. So farmers can, or anyone rather, like not just farmers, but as I said, EC, Environment Canada was using this as a project to determine if they can help control the algae growth in that section of Lake Erie. So it can help you determine any disease for agricultural field, especially. It can help optimize water, fertilization cycles and everything. The drones can detect exactly the plant health, even if there's just a section of crop that is not doing so well. They can then automate the whole system and have the program go out there and only put fertilizer on the section of the crop that was determined to be decaying or not doing well. So there's a lot of automation nowadays as well with drone technology, where you can have payloads that can actually go and spray the fertilizers as well, exactly where it is required based on the previous flight that was conducted, which determined the crop health. And so, of course, and then a real world application for this is environmental conservation as well. So it helps on a bigger scale if you're looking at deforestation, or even for disaster management. If there's been any forest fires or anything, these drones can go out and determine the extent of the damage that was done and also help control it. And then if there's any habitat loss or any environmental damage that's done, it can help quickly assess the issue and determine help the project managers or the relevant authority determine how they're going to be addressing the issues as well. So next project I'd like to discuss is mineral exploration. This was a very exciting project for me. I was up in northern Saskatchewan, in a very remote area in northern Saskatchewan along Cree Lake. It's completely remote. There's just one hunting lodge up there that we stayed at. So it was a very interesting experience. Excuse me. We flew the Aurelia X8 Max out there. So that was an eight prop drone, along with a magnetometer and a Medusa MS gamma ray spectrometer. So those are the two payloads that we had on this. So it was this drone is capable of carrying approximately 11 kilograms of weight. So we were close to that. We were at about 9.5 with these two payloads that we had. So the spectrometer basically detects any kind of radiation signatures in the Earth, and the magnetometer it picks up on magnetic anomalies of the Earth's crust, and it helps also to determine terrain and to help determine mineral deposits. So this project specifically, we were looking to we were looking for uranium deposits. So this was also a project sanctioned by Government of Canada to do some exploration of uranium deposits in areas where they were already kind of aware of possibility of uranium deposits being out there. But instead of going the traditional way where you have a land crew going out there doing exploratory work and damaging the environment when they're not really sure what's out there, this was obviously a much more sustainable way of conducting this survey, where we weren't disturbing any of the natural environment. There were moose out there were bears out there that we were aware of in the vicinity. We picked up some with our drones as well. So, you know, it was a really good way of not disturbing any of the natural habitat, but also getting an exact pinpoint of locations that they determined that uranium deposits were available in. So it was a really cool project. It helped us maneuver in dense vegetation, forested areas without any issues. And basically the output was getting a really high accuracy map of all the mineral deposit and overlaying it with the terrain. And then that would help the project managers later on decide exactly the areas that they would go and target if they were exploring further and looking to do the mining of the uranium. So these are just some pictures. This is the drone airborne with the magnetometer, which flies about 3 meters below the drone. And this is also to avoid any disturbance or any information and data it picks up from the rotors as well, because it's so sensitive. The rotors are also causing the magnetometer to pick up on the anomalies. But because we know that it's constant, we can always remove that from the data and pinpoint the data that is specific to the ground information. And this is Cree Lake here, and these are all the different islands. Some of these islands were the ones that we did the exploration or the conducted the flights on to determine where the uranium deposits were. So again, key benefits, we covered a large amount of area, like we did about 2,000 square kilometers, I believe, or more within a span of a few days. Obviously, we did have some weather concerns out there. Saskatchewan anyway is known to be very windy, so we did have some days where we were grounded because of the high winds, especially with the magnetometer swinging 3 meters down from it. We've heard of stories of the magnetometer swinging up into the props and everything. So there are obviously concerns as well, but as long as you're aware of the weather conditions, you know what you're doing, it shouldn't be an issue. And then of course the output is very helpful because it gives you so much data in such little time, and it helps you pinpoint exactly what you're looking for, so you're not out there wasting time and energy and having heavy costly equipment out there for days on end without knowing where you're actually going to be digging next, right? So it enabled us to have targeted drilling operations. This is a later on part, like we didn't have anything to do with the actual of additional exploration and digging of the uranium. This was just a project to determine where the uranium deposits were found in clusters, enough to enough to justify then going out there with digging equipment, right? And again, it contributes to a more sustainable practice rather than going out there with a whole field crew and disturbing the vegetation and causing stress to the natural environment. And it just, again, shows how drones can revolutionize mineral exploration compared to traditional ways, especially in challenging terrains such as northern Saskatchewan or anywhere out in the outskirts where it's so heavily forested. So the next project I'd like to discuss is contaminant tracking. So this was, again, a very interesting project. This was also a proof of concept and a pilot test that we conducted with one of our clients. So again, we used the DJI Mavic 300, Matrice 300 RTK for this project as well. But the payload that we attached to this was a LiDAR, a DJI Zenmuse L2, which is a LiDAR camera and RGB, and it conducts RGB imaging as well. So this, so LiDAR cameras basically, just a very quick overview is that they just emit lasers out at a frequency of the one we had set. The way we had set it up was it was doing 5 returns per second. So it was every pulse it shot out 5 beams that were shot back. So you can get a very detailed, high precision imagery of the surface that you're mapping. So the idea of this project was basically there's a decommissioned quarry that they wanted to map the face of to determine fractures that were in the quarry. So this quarry has been decommissioned for a while. They're looking to possibly do some redevelopment around that quarry for a residential area. So they wanted to determine if there's a possibility of the water that there's so much groundwater coming into the quarry at a daily on a daily basis. So obviously the groundwater has to go out, seep through the fractures as well. So what they wanted to determine is all of the fractures on the quarry face, and then they wanted to map those fractures and kind of construct a whole 3D image of the fractures going backwards into the rock, and to see if there's any possibility of any contaminants from that standing water in the quarry or the groundwater that seeps through those fractures and reaches the drinking water wells in the community. So this was a very, very cool project that we conducted. So we used the LiDAR to get really accurate imagery of the quarry face, and then that was basically we received a point cloud raw data for that, which was then converted into an entire 3D image, and then that was used by the team later on to construct a whole fracture network for the quarry. So a LiDAR, as I mentioned, it captures very detailed, accurate information, 5 returns per pulse, allowing for it to be super accurate, which you may not even see with the naked eye, like the little fractures and everything. And the RGB portion of it basically helps create a colorized 3D image as well. So it's overlapping both of those pieces of information for you so that you get a full 3D picture of the face that you're monitoring. So geospatial mapping is basically what we were conducting, and combined with the fracture data to help get this entire fracture network to determine contaminant movement, to simulate a contaminant movement through the rock face. So these are some pictures that I took with the drone as I was going through the quarry. So as you can see here, like there's a lot of different types of stone. Like there's the amount of detail that the LiDAR captures can help you determine the types of rock that is in there as well, whether it's limestone or anything. Like it can help you distinguish the layers of the rocks as well, and then get this entire 3D picture of what you're seeing in the field. Some of the key benefits, of course, high resolution data is collected. It was very, very rapid and cost effective. There have been obviously traditional methods where people have gone out and then they go down the rock face themselves and collect all of this information. It's very dangerous. We were, as you can see here, there's pieces of rock falling down as we were going through as well. So it was a very dangerous space to be working in. So being able to do it remotely with a drone obviously helped in the safety factor aspect of it. And it allowed for proactive assessment of the possible risk, right, of contamination traveling through this face rock and eventually reaching any of the drinking water wells. Of course, as I mentioned, again, this was again a pilot project, a proof of concept that the client wanted. So they're still working on the back end of it with the data that we collected for them. But that was the general idea, is to get any kind of assessment of what the contamination, how the contamination would possibly travel depending on the fracture network of this specific rock face. And it allows authorities to take early action by identifying potential contaminant pathways. And it obviously demonstrated, again, the value of RPAS based environmental monitoring and mining reclamation projects. As I said, they're possibly looking to rezone this into a residential area. So doing these kinds of tests early on and determining the potential for risks or contaminant travel is obviously very important. And the fact that it can be done in a timely manner and a cost effectively is also very important. So here's just, so this is from a different project, but this is basically what they are trying to determine is, get these model predictions for pollutant transportation. So this is a different quarry where this was conducted. And Figure A basically represents the point cloud with all of the colorization and RGB as well. It gives you the 3D map. Then the surface reconstruction gives you all of the millions of points that they're looking at. And then they basically would map that into showing all of these different various fractures that are in the rock phase, and then they would construct a 3D model of it going backwards and try to determine the fracture pattern and the network, which would eventually lead to the where they've got the monitoring wells about 5 or 8 kilometers away into the city, to see if there's any potential for contaminants from the quarry to transport through these fractures into the rock and to getting to the drinking water wells. So yeah, those were all the projects that I wanted to discuss today. This is Simba, as I said, he's our brand ambassador and our pilot as well. So in case, as I mentioned, RPASOTC, a remotely piloted aircraft systems operations and training corporation. So we do conduct operations, commercial operations for various clients all across Ontario and Canada. However, we also do train people who are interested in becoming a drone pilot. So if you are interested, I just wanted to kind of give a little bit of information about that as well. Which certificate is correct for you. So obviously this is regulated through Transport Canada. There are various different certifications that can be obtained depending on the kind of operations that you want to conduct. If it's just some basic operations where you don't expect to be anywhere within 30 meters of public or of buildings, and you're working in uncontrolled airspace, so that is that is away from any airports, airspace that is not federally controlled by the government, then you would just require a basic operations certificate. If you're looking for anything more advanced, like the kinds of operations that I discussed today, obviously you would need an advanced operations drone license where you are then allowed to fly in controlled airspace near airports and aerodromes, and you can fly within or over bystanders and near buildings. So that would require an advanced operations advanced operations certificate. And then if you're looking for, I'm sorry, for both of these, your drone has to be within 250 grams to 25 kilograms weight category. But if you are looking to do anything even beyond that, anything more, which requires heavier drones above 25 kilograms, or distance-wise, if you really need to go much further, if you're doing BVLOS, which is beyond visual line of sight. So the drone is no longer in your sight and you're conducting such operations, or if you're doing any kind of large events where you have a large group of people, or if you want to fly above 120 meters. So 120 meters is basically the maximum allowed altitude that you can fly within. But if anything above that, you have to get a special flight operation certificate and SFOC. So you can get that as well. I will just quickly take you to our website just so you can see. So yeah, RPASOTC conducts all of these drone training certificates for you. We have a course that you can attend, or if there's obviously an option of self-study as well, but then you would have to write the Transport Canada exam. And then for anything that is advanced operations or SFOC, then you also require a flight review to be done, which needs to be conducted by a Transport Canada licensed flight reviewer. So we do that as well. RPASOTC is recognized by Transport Canada as licensed school for conducting these courses and for training people. So we conduct flight reviews as well. So if you are interested, please feel free to reach out to us. We would be more than happy to answer any questions or train you if you're looking to do any of these operations. Sorry, that's my spot. And yeah, that's those are some of our clients that we work with. We have a lot of different universities that we have trained for different projects. There's a lot of different interesting projects that people are doing out there that we are training drone pilots for. We've got environmental projects where people are doing whale studies or any kind of vegetation monitoring and things like that. We've got a sensitive project that I actually would like to mention. We work with the Survivors Secretariat and we conducted a specific study for them where we did map an area that they had identified as potentially having some unmarked graves. So we used the M300 RTK along with the LiDAR camera to help them determine if there were any unmarked graves in those areas that they had identified, which was one of the projects that we conducted. We work with the various First Nations communities across Canada. We work with a lot of different universities for research-based projects. As I mentioned, 2 out of the 4 projects that I conducted were research-based and specifically proof of concept type of projects. So it's really getting very evident that drones are becoming very useful in different industries, and the traditional method of doing things is changing now, and drones are becoming more and more evident in all of these industries and helping be more efficient and cost effective. And as I mentioned, the main issue is human safety as well, right? So instead of risking someone's life out there in dangerous situations, drones are able to go and conduct the same kind of surveys and in fact get more information than what a human being might be able to achieve in a much shorter amount of time as well. And then yeah, that's it. So if you have any questions, I'm happy to answer.
Great. Thank you so much, Vaidehi. That was a wonderful presentation, a wealth of knowledge in such a short amount of time. It's great to hear. Thank you so much. We do have lots of questions. I'm just letting everyone gather their thoughts. We'll probably ask the panelists to join us soon if they have anything to add or if they want to jump into this discussion, but you've given us a lot to talk about. I'm not sure if we can get through it all. I hope the students that are in here were taking notes. I'd also like to thank the RPASOTC team for sharing their projects with us. There's some really interesting ones, and it's been great to see how you guys handle those projects and the lessons learned. And it's important to further the conversation in the education space with RPAS technology for, the improving education in this space. Okay, so the questions that I'll go through, the first one that we had, if you want to go back to the bathymetric slide.
Sure.
One of the questions that popped up during your presentation was, what was the max depth at which we can acquire data? And I'll just let you go through that slide again.
Sorry, just give me a sec. Trying to figure out how to get there again.
Sure.
Do you see my screen right now, or?
Yeah, we see Simba.
Okay.
We see the question slide. Okay, now you're going
Right.
back.
Okay. Okay.
Yeah.
Bathymetric, yes. Sorry,
Yeah.
I missed the question. What was that?
So the question was, what is the max depth, like the maximum depth at which we can acquire data?
Oh, the bathymetric, these eco sounders are good for, I believe, several meters. I'll have to confirm to be sure. I know the unit that we use specifically was for shallower depths, but there are other dual echo sounders that do a lot more deeper surveys. I'll have to confirm. I'm not exactly sure of the max depth that it can do, but I know that it can be several meters below. So the area we were mapping, we were already aware that the max depth was about 2.5 meters below surface. So we opted for this specific piece of equipment, but I know there are others that can go much deeper. Especially with the frequency and stuff, we have some that are 50 kilohertz frequency, which is very pinpointed and focused, so it can go much deeper as well.
Yeah, you did mention here that you were measuring at a shallower depth, not disturbing any of the wildlife.
Right.
Okay, great. So the second question popped up when you were at your multispectral NDVI slide. Yep, right there. The question that came up was, how are images georeferenced in the lake area? Are you using any ground control points? Are they necessary?
Yes, so we did have a few ground control points that we had measured using the RTK station, which is again a single, like a piece of equipment that you can hold, and it connects to the satellites and gives you the exact georeference point, and then everything is tied into those control points that we did that we had installed. So yes, it is georeference based on ground control points as well. And then the flight that is conducted, as I mentioned, each picture that was taken in this, and we had an overlap of about 80%. So every single picture is georeferenced as well, based on the RTK and then tied back into the ground control points as well.
Perfect. Yep. Thank you for that. Another question that popped up is, how does the software match images and select tie points to produce an orthophoto or an orthomosaic in a homogeneous area like a snowy region or a lake?
Yeah, so I think it sort of ties back to the previous question as well. We do have ground control points which are referenced predetermined ground control points that are tied into the entire survey as well. So each picture is georeferenced as well, and then it also all ties back into known points that we have already measured previously, and then it all ties in together and then gives you that reference. So we do conduct a lot of surveys that are, especially in the winter time, which is just snow, and the client is like, just see a blob of snow, but then because each individual photo is georeferenced and we have the known points that are already measured previously, it overlays it on top of that, and so it's consistent every time. So especially for surveys that we do on a continuous basis or recurring basis, we always go and tie into the same ground control points that we have measured right from the beginning. So when we set up our ground station, we choose one of these known points to set it up on so that it can be referenced back to that.
Perfect. Oh, and Dr. Ascari just popped in saying that the echo sounder, like the one that you're using, measures water depth between 0.5 and 200 meters. So that's just
200 meters. Yeah, that's pretty high.
perfect.
Thank you.
Another question that popped up is, do you use ground control points with Hydromagic?
With Hydromagic, yes. So with Hydromagic, it already had a lot of different maps, known points that we could download into the system as well, based on where we were, based on the geographic area that we were in. So you can just download those, and you can actually upload your own file as well, which has all of the ground control points that you have taken to cross-reference as well. But if you're already aware of the region you're in and everything, you can actually download they have downloadable maps and stuff that you can just pull into the system. So the picture you see here, actually, all of this back area that is being referenced is based on Hydromagic having pulled the map, and then we have overlaid our little map on top of that. So it gives you an exact reference of where you are.
Perfect. Thank you so much. Another question is, how much training is needed for an advanced pilot to use a sounder payload?
So the advanced drone operations is just, so we conducted in a 3-day course. It's just a 3-day course that you need to take. And then, as I mentioned, you would just take your Transport Canada Transport Canada exam online. And once you have completed and passed the exam, then you would reach out to a flight reviewer who can conduct your practical flight review. So the practical portion has certain tasks that you have to prove to it, like being able to take off safely, land safely, to conduct a survey of the area that you're in, to do weather checks and things like that. So once you conduct your flight review and pass, the reviewer will then upload your results to Transport Canada's website. And once they receive that, Transport Canada then issues you a license. So getting the license part is not very difficult, but the actual practical portion of it, where you're actually flying a drone manually and using all of these payloads, I mean, you would require a few few sessions of at least being out in the field and doing it, because it's a lot of maneuvering, because it's all manual flights. You can automate the flights as well with the Eco Sounder, but personally, from my experience, I found that just because of the uncertainty of the environment you're working in, because of like rocks being in the water and things like that, I found that the automated portion wasn't always very accurate. Like, there's so many safety features built into it that the drone kept stopping, right? So sometimes you have to be able to take manual control, and that does require a bit of having practice flying manually and stuff, especially with the payload hanging down from it, which is swinging and things like that. So, I mean, it depends on how fast you can learn, but at least a few sessions out in the field, in the real world, with the equipment, handling it, using it, being aware of what kinds of issues it can experience, and then being able to mitigate and control your drone, that would take a few sessions of being out in the field at least. So
okay, slight clarification. I think they're asking how much training is needed to use the Eco Sounder itself. So
there's no specific, like I did a 1-day training with SPH Engineering, which is the people from whom we obtained the equipment, and they basically teach you how to use the equipment. Sorry, I misunderstood, but yeah, it was just a 1-day training that they conducted online for using the Eco Sounder and all the features of it, and then they did a separate training for Hydromagic as well. You know how to do the post-processing of the data that you've collected.
Perfect. Okay, so we are just about finished for this session. We've got 1 minute left, but I wanted to ask, can I pop your email address into the chat box? If
yes, please do. Yes.
Yeah,
yes,
they can reach out to you directly. And one last question from my end: does Simba come with you guys into the field missions?
He does. He does come, and he monitors us and makes sure that we're doing everything correctly.
Yeah. He's your visual observer.
Sometimes, and then he tries to chase the drones sometimes, but yeah.
Perfect. I love that. You definitely need another spotter. So
yes, you always need a visual observer when you're out there doing advanced operations. So he's our visual observer.
Great. Well, thank you so much for everyone here at SAIT, at CFAL, everyone for joining us here today. This was a fantastic presentation. I'll let Francesco do the closing remarks.
Great. Thank you so much. I really appreciate everybody being out here. Thanks.
Thank you so much. Yeah, just to echo Michelle's thanks. Thank you so much for that great presentation. It was wonderful to see all the work that you do. Thank you, of course, to Michelle and the whole team at St. Sirius for all the support throughout the series. And thank you to everyone in the audience for taking the time to join us today and asking questions and participating. Just a few reminders, this session is being recorded and will be live on our YouTube channel, which you can always go back to and review, and please share with anyone who is in your network that might be interested in this today's session. Dr. Gary, thank you for posting the YouTube channel there in the chat. This is also an ongoing monthly speaker series, so our next session is on April 17th with Rahul Singh from Global Medic. So please join us for that session as well, and registration for the series is still always open until the very end, and free, so please feel free to share that to anybody who might not be registered yet but would be interested in the series as well. And with that, just one last big thank you to everybody again. I hope everybody has a great day, and that was a wonderful session. And yes, if you do enjoy our content on our YouTube channel, please consider subscribing and liking the videos, as that would always help us reach a bigger audience. So thank you so much. Yeah, have a great day, everyone.
Thank you.
Thank you. Thanks, everyone.